Okay, so you can see minimum SOP means sum of product for function A, B, C, D shown in K-map below. Okay, so what we have to take out? We have to take out the minimum terms out of this. Okay, so minimum terms we have to take out of this K-map. So the K-map is given to us. Okay, so to take out the minimum terms, first of all, we will see the larger group. Okay, so first of all, we will see the larger group and then we will come to the smaller group and again smaller group. So what is the definition of larger group? So it will be always to the power 2. Okay, it will be always to the power 2. So if 2 to the power 3 is the largest group, which is 8, then the smaller group again here is 2 to the power 4, which is 2 to the power 2 it will be. 2 to the power 2, which is 4, and 2 to the power 1, which is 2, and 2 to the power 0, which is 1. You can also take 2 to the power 4 also. Okay, so depending upon the maximum number of functions they give us. Okay, so likewise you have to do. Okay, so likewise you have to do the grouping. But first we will look for 8, then we will look for 4. So if we will look for the larger group, it will give us the minimum sum of product. Okay, and if we look for the smaller group, so it will give us maximum sum of product. Okay, but here in the question they have said that we want minimum sum of product for function A, B, C, D shown in the K-map below. Okay, so I hope you got the question. Let's see the solution for this. So let's do the grouping likewise. Okay, so let's see how the groups are made. So you can see here, like this is making a group, this is making one group. Okay, this is making one group, and you can also see that this is also making a group. So in minimum sum of product, we will consider 1. We will, wherever 1 is there, we will consider that. And in POS, product of sum, so we will look for 0. But here they are saying sum of product. Okay, sum of product. So that's why we will look for 1. And this X are the don't care symbol. Don't care symbol. Okay, these are the don't care symbol. Okay, so let's look for the 1. So here you can see that this will make a pair. Okay, this will make a pair. Yes, and now this one is left. So how we will cover this one? We will look for the corners. We will look for the corners. So here this is 1, this is 1, and this is 1, and this is 1. So this is the four group we have made. Okay, so 4 number groups we have made. So which is 1, 2, 3, 4. Okay, so now if you can see that we can make the group where the changing element is only 1. Okay, so we can make the group like here 1, 1, 1, 0. So here 1 and 0, only 1 bit difference is there. Only where 1 bit difference is there, we can only change, we can only make pair of that. Okay, so here also 1 and 0, only 1 bit change is there. Okay, you can see that you can see that here also only 1 bit difference is there. Okay, here also you can see that only 1 bit difference is there, and in this four elements group, which is 1, 1, 1, 1, I am talking about the corners. So here also you can see that this is 0, 0, this is 1, 0, this is 1, 0 actually, this is like this, and this is actually 0, 0, this is 0, 0. So this whole comes under 0, 0, and this comes under 1, 0. Okay, so this one and this one. So you can see that here the difference is 1 bit. The difference is 1 bit. So that's why we made quadrant. Okay, so that's why we made 4 elements group. Okay, so now let's see the pairs which we have drawn. And if you will see that if suppose, let me clear this. So if suppose we have one, let's suppose we have one here, okay, and we have one here. So can we make a group like this of 2? No, we cannot. Why? Because here if you will see that, this cannot be made. This cannot be made because here it is 1 1, okay, and 0 1, and here it is 0 1 and 1 1. So this cannot be made. Actually the group can be made in this way, okay, where this is constant and here the bits are changing by 1. But here if you will see, no one is constant here in both of them. That's why we cannot make the group horizontally, sorry, in cross way. Okay, we cannot make the group like this. So I hope you are clear, like from where we can make the group. And you can see that this is also not the way we can make the group, because this is 0 0 and this is 1 1, and here the bit differences is more than 1, so that's why this group cannot be made. Okay, so let's make the group earlier which we made, and let's see the minimum terms. So earlier first this group was made, so let's write the minimum term according to this. So the minimum term according to this is, so this will be a b bar, and here it will be this will get common, so here it will be c. So what is the first min term we got? A b bar c. Okay, now let's see for the second min term. So second min term we can get from here. Okay, so we can get from here second min term. So what will be the second min term here? This will be a bar, and from here we will get c and d bar. Okay, so this is the second min term we got. Now let's look for the third min term. So the third min term we can get from here. So here 2 elements are only forming one group. Why? Because 4 elements are not there to form a group. 8 elements we cannot form a group. So that's why we are moving for the smallest one. Okay. So here the group which is formed of 2 elements. So the mean term according to this is A C bar D bar. So now see, so all the ones are covered now. So you can only see that this one is left, but this is a single one. So we will first look for if it is able to form two elements group. So this is one element group it has formed. It can also be a 2 element group by this. Okay, now let's check for it whether it can form 4 element group or not. So yes, it can form 4 element group also by this, by covering this. Okay, by covering all the corners it can cover the 4 element group. Can you check that it can cover 8 element group? It cannot. So only 4 element group it can make. So what is the SOP of this is D bar, okay, D bar and B bar and D bar. So the SOP of this is B bar and D bar. So if you can see here, so this will be B bar, and if you will see from here, it will be D bar. Okay, so we have got the 4 minterms. Okay, so 4 minterms, let's write them. So the first minterm we got is, okay, so the first minterm, let's write the first minterm. Here we got, which is B bar D bar plus A bar C D bar plus A C bar D bar plus A B bar C. So these are the minimum min terms which we got from this K map. Okay, so always remember, like, to form a group with larger elements, and it should be the power of 2, like 2 to the power 3 which is 8, 2 to the power 4 which is 16. So it should be the power of okay, 4. Sorry, it should be the power of 2. Likewise I said it should be the power of 2 to the power 3 if it's there, so it will be like 8 elements group. Okay, if it is to the power of 2, so it will be 4 element group. So if you will form the group likewise, so you will get the minimum variables out of this. Okay, so see, as you can see that this is the power of 2. Okay, so this is the 2 element group, and how many terms are there? 1 2 3, 3 are there. Okay, 3 variables are there in it, and this is the group of 4. So how many variables are there? Here are 2 variables. So likewise, the larger group you will form, the minimum variables you will be using. That's why it is considered to use the larger group first and then to go for the smaller one if larger is not forming. Okay, so this is what it is advisable. So I hope you got the question very well. Now let's move on to the next question. Okay, so let's see the next question. So the next question says, which one of the following statement is not true? So not true means which is false, that we have to identify. Okay, so here the options are given to us. So this is the option A, this is the option B, this is the option C, and this is the option D. So 2 into 4 line decoder may act like a 1:4 demux and vice versa. So this is absolutely correct, because 2 into 4 line decoder may also act as 1 4 demux and vice versa. So this is the statement, it is absolutely correct. And if you will see the second one, so a decoder with enable input can function as a demultiplexer. So this is also correct one. A half adder or half subtractor circuit can be implemented by 2x4 decoder and OR gate. So this is also correct. So these are the theoretical statements which they have made. Okay, so these are all the correct ones. Above A to C are the correct ones. And if you will see that demux can be used as an universal gate, so this is false. You know what are the universal gates, right? So this demux can be used as universal gate, which is absolutely false. So the answer is D. Now let's see the reasoning of this. Let's see the reasoning. So demux can be, so the demux cannot be used as an universal gate. Okay, so why this is because a universal gate is one that can be implemented any Boolean function. That means through this demux, we should be able to derive and, or, NAND, NOT, XOR, XNOR, every Boolean function, it should be implemented. So if it is implementing, that's why that's where it is called as universal gate, but it is not able to derive. Okay, because it is not able to derive some of the Boolean functions, so that's why this is not universal gate. Okay, so whereas a demux can only implement a specific type of function. Okay, can only implement a specific type of function. So that's why this is not universal gate. Okay, so in contrast, gates such as NAND and NOR are considered okay, universal gates. You all know this, that our universal gates are NAND and NOR. Okay, this is due to, so let me write this point in the next page. So this is due to the fact that both NAND and NOR gates can be used to construct all other fundamental logic gates, which is AND, OR, NOT, and it can be XOR, XNOR. Okay, so all other it can be able to construct. So that's why they are called as logical. That's why they are called as universal. What it is called, universal gates. But here demux cannot implement some of the Boolean function. So that's why this is not considered as, demux is not considered as universal gate. So I hope you got the clarity why demux can be used as an universal gate. So this is actually a false statement for us. Okay, this is actually a false statement. Okay, so let's move to the next question. So the next question is, the minimum number of literals after simplifying the following Boolean expression. So what you have to do, you have to minimize this Boolean expression. Okay, so let's write this Boolean expression, and after that you have to find the literals. Literal means the variable present after minimization, that is called literals. Okay, so let's write the expression xy plus x w z plus w z bar and multiply by wy plus w y bar. So this is the whole expression given to us. Okay, so now what we should do? Okay, so first, if you can see that we can take common here w, and here in this expression also we can take common w. So let's see, after after taking common, what we can derive. So xy we will write as it is, plus x we will write as it is, but now here we are taking out w as common. Okay, rest of the expression, so if w will taken as common, so here it will be z plus z bar. Okay, so this it will remain, and after in this expression also, if we will take out w, so what it will be? It will be y plus y bar. Okay, so this is the whole expression has become now. So as you can see, as you can say that a plus a bar is always equals to 1. Okay, always equals to 1. If you will consider here a value as 0, so it will be 0 and a bar of 0 will be 1, so the expression will be 1. If you consider the a value as 1, so it will be 1 plus 0, so always this plus is considered as the OR in digital. Okay, so it will be 1. So to make OR 1, one of the one of the term or one of the gate should be 1. So the whole expression will comes out to be 1. So this is the method. Okay, so now as I said, let's write this likewise as it is, and as I said that this z plus z bar will become 1. Okay, so it will become 1. So it will become 1, and here also if you will see, this term y plus y bar will also become 1. Will also become 1 here. So this is, I will write here like a plus a bar is equals to 1. So this is the property we have used. So now this the expression will be x y plus x. So w into 1 will be w, w into 1 will be w, and here in digital w into w is not w square, it is only w. So you should know this point that w into w is always w, it is not w square in digital. Okay, so w into w is only w. So this point also please keep remember. So the answer will be w. So now here if you take x common after this, okay, so after this if you will take x common, so it will be y plus w, or you can write it as, yes, so this is what the term which is taken out. Okay, so this is, we have first simplified the Boolean expression, and now this is the simplest Boolean expression we have taken out. So what they have said, find the minimum number of literals. So let's count the minimum number of literal. So it will be 1, 2, 3. Okay, so 3 literals are there. So minimum 3 literals are there. So what is our answer? Our answer is 3. Our answer is 3. Okay, so I hope you got the explanation. Let's move on to the next question. Okay. So here, let's see what the next question says. Which of the following diagram 4 into 1, 4, 1 marks implements XNOR gate? So we have to see which implements the XNOR gate in this. Okay. So if you all know that this is 4:1 marks, okay, so what is the output of 4 into 1 marks? 4:1 marks. So 4:1 marks. So the output for this is x s1 bar, s0 bar, and this is I0 plus s1 bar S0 into I1 plus S1 S0 bar, this is I2, plus S1 S0, this is I3. So this is the output of 4:1 multiplexer. Okay, now as in the question they have given us, S1 equals to A, S0 equals to B. So you have to put, all this term in this output, and we will check the option one by one. So this is the option A. Let me write, this is the option A, this is the option B. Okay, and here so here it will be the option C. Okay, this is the option C and this is the option D. So let's put these input, in the expression, and let's see what the output comes. So if you will see that I0, the input is 0. Okay, so let's put one by one. So what the expression will be? So the expression will be A bar, B bar. Okay, I think this is not much visible. So for the much visibility, let's check this. Just this. Let's write this. Okay, so it will be A bar, here B bar, C. This we are putting here. Okay, and the I0, what in the first option I0 is 0. You can see I0 is 0. So we will write 0. Plus now S1 is A bar, S0 is B. What is the input? Here I1 input is 1. So it will be 1. Plus S1 will be A bar, S0 will be B, and what is the I1? I1 here is, sorry, this expression we have completed. Now let's look for this. So if you will see this expression, okay, so here this expression we were writing, so it will be A, B bar, and in the I2 it is 1. In the I2 it is 1. So plus AB, and what is the I3 value? What is the I3 value? It is 0. So 0 multiplied by 0, it will be 0. This will be A bar B, plus this will be A B bar, and this term will be 0. This term will be 0. So as you can see that this is the option A. So this is actually A bar B plus A B bar. So this is nothing but the XOR gate. This is nothing but the XOR gate. Okay, but in the question they have asked for XNOR gate. So this is the option A, which is giving us XOR gate. So in the option they have asked for, in the question they have asked for XNOR gate. Okay, so let's see for the XNOR gate now. Okay, so let's see the option C. So let's see for the option B. So our S1 was A, our S0 was B. Okay, So let's look for this. So let's put, now here again it will be a bar, b bar, and this time I0 is given as 1, plus it will be a bar, b, and I1 is given as 0, plus again it will be a, b bar, I2 is given as 0, and in AB here I3 is given as 0. So this term will be 0, this term will be 0, this term will be 0. Okay, and what this term will be? A bar, B bar. Okay, so it will be A bar, B bar, which is nothing but NOR gate. Okay, which is nothing but NOR gate. So option B is NOR gate. Option B is NOR gate, because A, B, and here complement becomes the NOR, and if you will apply De Morgan's law, so it will be A bar, B bar. So this is what the expression we got. So that's why this is NOR gate. So option B is NOR gate, but we want XOR gate. So again we will check for the option. Okay. So let's check for the option C. Now in the option C, let's put one by one. So it will be A bar, B bar, and now I0 will be 1, plus A bar, B, now I1 will be 0, plus A, B bar, I2 will be 0, plus A, B, and here I3 will be 1. Okay, now if you will see that this and this term will be 0. So what is the form? A bar, B bar plus AB. This is what we got, and this is exactly the XOR. This is exactly the XNOR gate. So which we want this in the so which is required in the question. This is the XNOR gate. So option C is the correct option. Okay, so let's mark option C. Okay, so let's mark the option C here. So option C is correct. Okay, but for the practice purpose, let's again solve for the option D. So if we solve for the option D, so how the expression we will get? It will be A bar, B bar, and in the option C this is 0, A bar, B, I is 1, plus A, B bar, here I2 is also 1, plus A, B, I3 is 1. Okay, so this is what it is. Now this term will be 0, so this is, we will cancel out. Then we will get A bar B plus A B bar plus AB. So this is the term we will get. Now if we will take common between this and this term, so it will be B, A bar plus A, and it will be A, B bar. Like this it will be. Now here the expression will be B plus A, B bar. Okay, A, B bar. Now we will apply the property, which will be, see here I am applying the property, it is B, A, okay, this is the distributive property, okay, and B plus B bar. So this will comes out to be 1, and this will be B plus A. And this OR expression, this is the OR gate, okay, it is commutative also, so it will be A, B. So this is the none other than OR gate expression we got. Okay, this is none other than the OR gate expression we got. So option D is also incorrect, as we all know. So this is the distributive property. Let me write how the distributive property is. So let's erase this first and I will discuss the distributive property. So distributive property, it is B plus A bar B. Sorry, it was A B bar. So in this property, what you have to do, you have to multiply B with A and B with B, and in the middle it should be plus, like in the middle it should be multiply, like C, B plus A multiplication is in middle, and again b plus b bar. So this is the distributive property which we have used, distributive law. Okay, so this will comes out to be a plus b. As this expression is commutative, so we can write a plus b also and b plus a also, it is all the same, and this will comes out to be 1, and 1 into this expression will be a plus b itself. Okay, so I hope you got the explanation. Let's move on to the next question. Okay, so in this question, which of the following binary code for decimal digits are self-complementing? Okay, so let me give the options. So the option for this question is, option A is 8421 code, option B is 2421 code, option C is access 3 code, and option D is access 3 gray code. So these are the options given to us. Okay, so let's see first what is self-complementing. Let's see the term what is self-complementing first. Okay, so let's write the solution in the next page. Okay, so self-complementing code have the property that the nines complement of a decimal number is obtained directly by changing ones to zeros and zeros to ones. So this is the complementing, you already know. Okay, so the complementing, you all know that it is like changing from 1 to 0 or 0 to 1. So for example, I'll give you one example, so which is 0 1 0 0. So if you will do the complement of this, so it will be 1 will change to 0, this 0 will change to 1, this 0 will change to 1, and this 1 will change to 0. So this is what it is. So self-complementing code have the property that the nines complement of a decimal number is obtained directly by changing 1 to 0 and 0 to 1. So 9 complement if of a decimal number, okay, is obtained by changing 1 to 0 and 0 to 1. Okay, now what are the necessary conditions of self-complementing? Let's see that. So this is the part of definition. Now let's see the necessary condition for the weight code to be self-complementing so it is that the sum of its weight must be must be equal to 9. Must be equal to 9. So in option A, you can see that 8 plus 4 plus 2 plus 1. So what is the weight? Here it is 12, 13, 14, 15. So which is not equals to 9. So that's why the necessary condition here is failing. So that's why option A is not correct. If we will go for the option B, so it is 2 plus 4 plus 2 plus 1. So this is 6, 7, 8, 9. So which is equals to 9. So that's why option B is correct. It is self-complementing. Okay. And access 3, if you will see that access 3 code is also self-complementing. So please remember this, that access 3 code is also self-complementary. Okay, access 3 code is also self-complementary, and access 3 gray code is not self-complementary. So as such, no much explanation is required to this, because this is a kind of theoretical type of question. Okay, so the necessary condition you have to check for the weightage, which should be equals to 9. So option A is not equals to 9, option B is equals to 9, and the access 3 code is self-complementary, that you should keep remember, and access 3 gray code is not self-complementary. Okay, so the correct options are option B and C. Okay, so let's write it. So B and C are the correct options. Okay, let's move on to the next question now. Okay, so this is our next question. I should give you the options for this. So the option A is A bar C bar plus A B bar C bar D plus A B bar C D bar plus ABC. Then option B is A bar C bar plus B bar C D and A B bar C D bar plus ABC. And now if we will see for the option C, so it is A C bar plus A B bar C bar D plus B bar C D bar, and the option D is none of the above. None of the above. So these are the options given to us. Okay, so let's see the question first now. If function 1 is given a b c d, okay, if function 1 is given a b c d, and here now the mean term, so the mean term expression is given as 0, 2, 5, 7, 9, 11 and 13, and the function 2 is given as a b c d, and again the mean term expression values are given as 1, 2, 4, 7, 10, 11, 13, 15. Okay, so this is what it is given. After that, they are saying here to do XOR between F1 and F2. Okay, so the minimal SOP expression will be, if you will do XOR on F1 and F2, so what the minimal SOP expression will be. Okay. Okay, so let's solve this question. So first let's write our function, which is f1. So it is a, b, c, d. It is given to us. Okay, so the mean term values they have given us 0, 2, 5, 7, 9, 11 and 13. And here the F2 is given us A, B, C, D itself, and the values they have given here in the F2 is 1, 2, okay, 1, 2, 4, 7, 10, 11, 13. So this is 13 and 15. Okay, these values are given to us. Now you have to do XOR between F1 and F2, and then you have to take out the mean term values. Okay. So in XOR, whatever, so if you have this function 1 and function 2, whatever the values which are common, you have to exclude that. Okay, so here I guess one value is missing. Okay, so whatever the values in this two which are common, you should not take this in the mean term, and which are not common, that you have to take. So let's suppose here 2 and 2 is common, so you will not take it in XOR gate. Okay, you will not consider this in this minimum term. Okay, so let's check. So 0, so let's write this. So 0 is not present in both of them, so that's why we will consider 0. 1 is not considered in both of them, so we will take 1. Now if you will see 2 is present in both of them, so common you have to not take. 5 is not present in both of them, so you will consider. So first of all, let's see for the smaller one, which is 4. So 4 is not in any of them, so you will take 4. After that 5 is also not any one of them, so you will consider 5. 7 is common, so you should not take that value. 9, if you will see, is not in any one of them, so you will consider 9. 10 also, if you will see, is not in any one of them, so you will consider 10. Now 11 is common, so common you should not take. 13 is common, so common you should not take, and the value which is left is 15. So 15 you have to take. So whenever you will do XOR of two functions, so the common values you have to eliminate, and the values which are not present in both of them, so that you have to consider. So these are the minimum term values. Okay, so now let's go for the out of this, what you have to find in the question. They have set for the minimal SOP expression, so mean terms you have to find out by this. Okay, so the better way to find out here is using the K-map. So let's draw the table for that. So you should require 4x4 table. Okay, so this is the table which is required. Okay, so this is the table I have inserted because the lines may not be that clear. So okay, so let's see this. So this will be 0. This is not visible here. Let's see if the color changes for this table. So let's not consider this table. Okay. Okay, so let's change. So this is not which is very visible. Oh, okay, so let's consider this as table. Okay, yeah, this is perfect. Okay, so this is actually 4 cross 4 table because the elements here given as 1, 2, 3, 4. So that's why. Okay, so this is the consider this is as K map. Okay, now here it will be AB and here it will be CD. Okay, now here it will be 0, here it will be 1, here it will be 3, here it will be 2. Okay, then here it will be 4, here it will be 5, here it will be 7, here it will be 6. Okay, and now here it will be 12, here it will be 13, then 15, 16. Okay, this is 8, this is 9, this is 11, and this is 10. So I hope you got the numbering. Okay, so this is how you should do the numbering. Now let's put this number. So we have to find the minimum. So you will place 1 in the table. So let's put it. So in 0 you will place 1, in 1 you will place 1. Okay, and in the 4 you will place 1, in 5 you will place 1. Okay, here in 9 you will place 1, in 10 you will place 1, and in 15 you will place 1. Okay, so these are the ones we have got. Now, okay, so now what you should consider? You should consider the larger group which possibly we can make here. That group you have to consider. Now let's make. So this is the 4 element group. You can see that we can form here the 4 element group which we can form. Okay, so what the expression according to this it will be. Okay, so let's write here 0 0 0 1 1 1 1 0. It will be 0 0 0 1 1 1 1 0. Okay, so this is how 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. Now the group this is formed. So let's see what the minimal expression comes out of this. So it will be A bar and here it will be C bar. So the first minimal expression we got from this is A bar and C bar. Okay, so A bar and C bar is the term. Now let's look for the other one. So which is, so see this I said earlier like this group you cannot make. Okay, so this is the possible group which you can make, this and this one. 2 element group you can make. Okay, and as you can see that here, yes, so this is the possible group you can make because this and there, this, the bit changing in here is 1 difference. So the bit changing difference is 1. So yes, you can consider this group as well. So what will be the minimum expression we will get? So plus. So the expression we will get is, here it will be B bar and it will be C bar and D. So this is what we will get. Now as you can see that here you can't make any group and here also you can't make any group. So these two are the ones where no group is possible from anywhere. So you have to directly take it as, so see if 8 element group is not possible, we will come to 4 element group. If 4 element group is not possible, we will come to 2 element group. And if 2 element group is not possible, we will come to 1 element. So this is exactly what it is formed. Okay, so here 1 element group. So how it will be? It will be A, B, C, D, this one. And the other one will be, I'll write it. So it will be A, B bar, okay, A, B bar, C, D bar. So this is the minimal expression which we have taken out. So let's check according to the option, which is the correct answer. So according to the option B is correct. According to the option B is correct. Okay. So let's write down B is correct. B is correct. So what learning you got from this question? That when you will do the XOR of two functions, so at that time you have to consider, you should not take the common elements. Other than common elements you can consider. Then you have to make the K-map. Then you have to do the grouping. First you will see the larger element grouping. And if the larger element grouping is not possible, you will see for the smaller one. And if the smaller one is also not possible, then you will see the grouping of one element itself. Okay, so this is how you have to do, and after that you will get the minimal SOP expression which is asked in the question. So in this question 2 learnings you got. Okay, so let's move on to the next question. Now this is the question they have asked. So here if we read the question, then consider the two functions. So again the two functions are given, function 1 a, b, c, d. Okay, these two functions are given, and here the values are given as 1, 3. Okay, so here the maximum terms given. Okay, maximum terms given 1, 3, 5, 11 and 15, and f2 is given as a, b, c, d, and the max term given here as 1, 3, 1, 3, 5, 7, 8, 9, 11. Okay, so this is what they have given. So now what will be the f3 equals to f1 plus f2? So this is not plus, this is actually OR. When expressed as the product of max terms. Now you have to do the product of max terms. Okay, so let's first see this. Let's first write here f1. Here it will be a, b, c, d. So what the expression they have given us 1, 3, 5, 11 and 50. Now you have to convert this in mean term like here, and then you have to find the max out of this. Okay, product of max term. So let's consider this. So here these are the max terms. So what will be the mean terms here? It will be 0, 2, 4, 6, 7, 8, 9, okay, 10, 12, 13 and 14. And these are the mean terms and these are the max terms. Okay, now similarly we will take out for the f2 also. So for the f2 it is a, b, c, d only. Okay, so let's write this in the new page. Okay, so let's write it. So first you have seen for the f1. Now let's see for the f2. So it will be a, b, c, d. Okay, and the max term they have given us 1, 3, 5, 7, 8, 9 and 11. Now let's take out the mean terms. So what will be the mean terms? Here it will be 0, 2, 4, 6, 10, 12, 13, 14 and 15. So this will be the mean terms. Now if you will do OR of f1, plus F2, which is equals to F3. So what will be the max term product? So here it will be 1, 3, 5 and 11. Simply it will be 1, 3, 5 and 11. Okay. So in the OR, you will have to take out the common terms. So what are the common terms in F1 and F2? So it will be 1 is common, that's why this here it is 1. 3 is common, so that's why here it is 3. 5 is common, so that's why here it is 5. 7 is not common, 8 is not common, 15 is not common, so that's why we haven't considered this. 11 is common, so that's why 11 we have taken out. Okay, so this is how we will do when we have to ask about the product of max term. And these are the mean terms. These are not related to question, but if these are max terms, so what will be the mean terms? So likewise I have shown here. Okay, but if we will not consider this also, then also we can get the answer from the question itself, like whatever the common are there, that we will take out, in F1 plus F2. So this is the common one we have taken out, and this is the answer for this. Okay, so I hope this question is clear. So the answer is 1, 3, 5 and 11. Okay, so let's move on to the next question. So the question says, for the given ring oscillator, the progression delay of each inverter is 50 picosecond. So 50 picosecond is written as 50 picosec is written as 50 into 10 to the power minus 12 seconds. Okay. What is the fundamental frequency of the oscillator output? So you have to find the frequency of the oscillator output. So here, how many NOT gates are given? Let's count 1, 2, 3, 4, 5. So n we will consider as the number of NOT gates, which is 5. Okay, and the TPD. Okay, so time for progression delay. So it is given as 50 into 10 to the power minus 12 seconds. Now let's apply the formula for the frequency. Okay, so the formula for the frequency is F equals to 1 upon 2n TPD. So this is the formula for the frequency. So let's put the value 1 upon 2 into n value is 5, TPD value is 50 into 10 to the power 12. Okay, so if you will do the calculation, so this will comes out to be, okay, so let's calculate this value. 1 upon 2 into 5 to 10 to the power minus 2. Okay, so now this we will bring upwards, so this will 10 to the power 12. Now this is 10 into 50 if you will do, so it will be 10, 12, so this will be 500, so which is 10 to the power 12, so 5 into 100, okay, so which is 10 to the power 12, so it will be 5 into 10 to the power 2, so it will be 10 to the power 10 by 5. So if you will do the further calculation, so the value will comes out to be 2. So this will be the answer. Okay, so 2 is the answer, and here the unit is given to us. So our answer is 2 in this question. Okay, so it will, if you will do this, so 10 into 10 to the power 9, and here it is 5, so 5 ones are 5 twos are. So like this we will have the expression here. Okay, so like this 2 answer will come. Okay, so let's move on to the next question now. So the next question is, the Boolean function obtained by inverting the Boolean function obtained by adding an inverter to each and every input of AND gate is. So the options given here are OR, B is XOR, B is XOR, C is NAND, C is NAND, and D is NOR. D is NOR. So let's see. So the Boolean function obtained by adding an inverter to each and every input of AND gate is, okay, so every input, if you will apply AND gate, so it will be, so A, B, and inverter is applied to each and every input. So inverter, it means NOT gate, so it will be A bar and B bar, like this it will be. So this is equals to A plus B the whole bar. Okay, so this is what the expression comes out to be. And please keep remember that bubbled NAND bubbled AND gate is always equivalent to NOR gate, is always equivalent to NOR gate. As you can see that every input is inverted. Inverted means applied NOT gate. So A bar, B bar. So the expression will comes out to be NOR. Okay. So this is actually the bubble input. Bubbled AND gate is equivalent to NOR gate. So let's suppose here if we have input A. So here if we have input A and here if we have input B. And this is AND. Okay. Wait. Let me draw it properly. So this is two input. This is AND. And this is A, this is B. Now they have said that to apply the bubbles. Okay, so to apply the bubbles, it means let's put the NOT. So the input will be A. Now here NOT is done. Here B, NOT is done. And now here the input is applied. So here it will be A bar. Here it will be B bar. And the AND gate we have performed, so A bar, B bar. Like this it will be. And this is, and if suppose if we didn't write this, so this is also equals to this if we apply this bubbles here. So that's why the bubble AND is equals to the NOR gate. Okay, it is equals to the NOR gate. So that's why option D is correct. So option D is correct. Okay. So let's erase this. So the correct option is option D. Option D is the correct, which is NOR. Okay. So let's see for the next question. Okay. So this is the question given to us. Now, okay. So in the circuit shown below, the propagation delay of each NOT gate is 2.5. Okay, 2.5 nanoseconds. It is given. The time period of the generated square wave is. Okay. So now we will always consider the NOT gate in the square wave. So how many NOT gates are there? 1, 2, 3, 4, 5. So NOT gates we have are 5. Okay. Now they have given the propagation delay time they have given. So they have given us TPD. So which is 2.5 nanoseconds. Okay. Now they have asked us for the time period of generated square wave. So time period we will denote as T. And if we will write the formula, what is the time period formula? So it is 2n TPD. 2n TPD. This is the formula for time period of generated square wave. Okay, so let's put the value for this. So this is 2, n value is 5 and TPD value is 2.5 into 10 to the power 9 nanosecond. So the answer comes out to be 25 nanoseconds. The answer comes out to be is 25 nanoseconds. Okay, so the answer is 25. Now here the last inverter, if you will talk, so the last inverter is only used to invert, and delay is only used to invert and delay the generated square wave. And in the formula we should also always consider the NOT gates which are in the square wave. Okay, so I hope you got the explanation. Let's move on to the next question. Okay, so this is the question given to us. So let's first write the options for this. So option A is, so you have to consider the output for F and G. So F equals to ABC plus A bar D. Option B says G equals to ABC plus A bar D. Option C says F equals to ABC plus A bar D bar. Okay, and option D says G equals to ABC plus A bar D bar. Now let's see what the question says. So the question is given, which of the following statements are true for the circuit given A, B, C, D as input variables, and what are the following outputs for F and G? So you have to calculate the output for F and G. So let's see this. So this is the input A. Here it will be A bar. Okay, here it will be A bar. Here it is, the output will be BC. The output will be BC. And here, now if you will see that this is connected with this. So the output here will be, so this is the output A bar and here D. So the output will be A bar, D and this bar because of NAND. Now this output is connected to here. So it will be A bar, D whole bar and the whole bar because this is NAND. Okay, this is NAND. And now here what this will be, what will be the output of this gate? So this will be A bar itself. This will be A bar plus here the output will be BC. Here the output will be BC and this is connected to this. So this is connected to this. So it will be, this one will be one expression and the other expression will be A bar plus BC. So this is the F. So let's minimize the F. Let's write the F first. So the F will be A bar. Okay. So it is A bar D the whole bar, and on this the whole bar this is present, and the other will is A bar B C. So let's solve this. So if we will solve this, so it will be first A plus D bar. Okay, and here A bar is there and again the bar is there. So now this will be A plus D bar and the whole bar again. So now it will be A plus A bar D. So this is how the expression will be, and this expression we will write this as it is A bar plus BC. A bar plus BC we will write. So this is for the F we are calculating. So now we will apply the distributive property. So it will be a plus a bar, and here it will be a plus d. Okay, and here again it will be, okay, so let's keep this as it is. Now this will comes out to be 1. So a plus d, and here it will be a bar plus bc. Okay, so this is how the expression will look like. Now let's see, let's multiply this a in this. So this a is multiplied with a bar, so it is 0. A is multiplied with bc, so it will be abc, plus this a is multiplied with d, so it will be a bar d, and plus this is multiplied with d is multiplied with bc, so it will be dbc. So okay, so this is not visible to you. Okay, so let's erase this first, and let's write the expression which is given. Okay, so this is the so after this line I am writing here the expression which is formed is abc plus a bar d plus dbc. So this is the expression we got. Now let's minimize this. Okay, so this is the extra dbc we are getting. So somewhere we have done this wrong. Let's see this again. Because one extra expression is coming, rest expression was correct. Let's just look for the f first. So this will be a bar. Okay, let's see for this expression only. So this is the a bar, and now this so it will be bc. Okay, it will be bc, and now here if we will take, so a bar is coming and here bc is coming, so it will be a bar plus bc, like this it will be. So this is what this input will be, and here the input will be a bar. Okay, and now here this is the input which is coming right from here. So here it will be already a bar d, and this is, so let's simplify this here itself. So it will be a plus d bar. Okay, so now here it will be multiplied with a plus d bar and the whole bar So let's first simplify this here itself. So it will be 0 and then a bar, d bar and the whole bar. So this is how it will be. So this is the input for, so this will be the input. So now it will be a plus d. A plus d is the minimize. So this is the input, a plus d. Now a plus d, here it is answer, it will be in multiplication. It will be a bar bc. Okay, so now if we multiply this, so it will be 0 plus, if we multiply here a bc, and if we multiply here this with it will comes out to be a bar d plus, and this if we will consider, so it will be dbc. So like this it will be. Now if we will take, let's take abc plus a bar d plus dbc. Now here you can see that this we can take common. So bc plus a plus d, and here a bar d. Okay, so this is we can take common. So if we will multiply, if this is multiplied, okay, so this is only the final expression which is coming. Now let's minimize this using K-map. So if we will do the K-map, so I am showing you the rough diagram of how the K-map will be. Okay, so it will be here it will be like 16 columns we will have, 16 blocks we will have. So 1, 2, 3, 4 and here also it will be 1, 2, 3, and let's suppose here it is 4. Let's suppose here it is 4. Okay, and here this is AB and this is CD. Okay, so now here you can easily write the numbers. So by writing the numbers, what we can see that here 1, 1, 1, 1, here it is formed, and again here it is forming 1 and 1. Okay, here it is forming 1 and 1. So if we will make this group, okay, let me use the other this. So likewise we will make, which group we will make? We will make this group of 4. Okay, and we will make this group, or we can make this group also. We can make this group also. Okay, so this we can make. So now if we set this, so this is a bar d, and here this expression is ABC. This expression is ABC, and this vertical expression is DBC. This vertical expression is DBC. Now if you can see that here with ABC itself this is covered. So this is the essential prime implicants, and this is the alternate which is overlapped one. Okay, which is overlapped one, so we can easily delete this. This is not at all required. This is not at all required because this is the overlapped one. Okay, so if we will remove this, still you can see that the ones are covered. Still you can see that the ones are covered. Okay, so either you take this or you take this, but if you will take this, so this one will be left. So that's why this is not that essential. So this is not that essential. So that's why what we did, we take this horizontal one. So the horizontal one will give us ABC, and this 4 group will give us A bar D. So this is how you can eliminate this using K-map. Without using K-map, you cannot minimize this expression. Okay, because you will not able to see that this is the overlapping one. This value is the overlapping one which you cannot see. Okay, so that's why what is the expression for A? It is ABC plus A bar D. So option A is correct for this. So F expression we got. Now let's see for the G. Okay, let's see for the G. So see, this is also one of the learning which you got, that if you are not able to minimize the expression from here, use the K-map. There you can see that which element is overlapping and which is not, which is required element, which is essential essential expression, that also you can get through K-map. Okay, so here in the options you can check, because because earlier we were not able to minimize the expression. That's why we made K-map. And in the K-map, we saw that one pair is overlapping, which is not required, so that we can eliminate. And here the minimized expression we got. Okay, so let's see for the option G now. Let's see the output for option G. So it is, so for option G, so yes, so let's create this. So this is BC. Okay, and here it will be A bar D and the whole bar, so which is A plus D bar. Okay, so this is one of the input, and now the expression will be A bar plus BC. This is the input, A bar plus BC, and the other input here it is A plus D bar. Okay, so these are the inputs we got. Now let's multiply them. So it will be 0. Again it will be A bar D bar. Now here it will be BCA. Okay, and it will be D bar BC. So this is the expression we got. Okay, so these are the expression we got, and again here also the problem here is Like if we write a bar d bar, we can write here it is ABC, and this we can write it as BC d bar. So this we can write. So again also if you will try to minimize like this, so it will not get minimized. But if you will make the K-map for this, like I made the K-map for F, you will see that one of the pair is overlapping, and the overlapping pair will be this. Okay, overlapping pair will be this. So you should not consider the overlapping pair. You should consider, see, in K-mapping, what is the rule? That all ones should be covered. All ones should be covered for one time. Overlapping should not be there. Okay, overlapping it is there, so it is not the minimal expression we are getting. Okay, so if all the ones are covered without overlapping, so that is what we will consider as minimal expression we got. Overlapping one, we should eliminate that. So this will be the overlapping one expression, that's why we are cancelling it. And this is the minimum one, which will be of four elements. So a bar d bar will be that expression, and the two elements covering, so it will be ABC. So that's why if you will see that, so the expression we got here for G is ABC plus a bar d bar. So that's why here option D is correct. So G expression is this and A expression is this. So make K map for this, and as I have shown the K map for F, and we eliminated the overlapping pair. So please try and check for G also. It is that easy. Likewise we made for F. It will be similar to like that of G. So you will get that this pair is overlapping. So that's why we eliminated that. So I hope from this question you have got a very good learning. Like you should make the K-map if you got stuck in minimizing the expression. And if some overlapping pair is there, so you should not consider that, because we want the minimum number of pairs which is covering one. Okay. So I hope this question is clear. Let's move on to the next question. So after simplifying Boolean function f is xyz, and the minterms they have given is 0, 2, 4, 5, 6 we get. So let's write the option for this. So it is f equals to z plus xy. Option B is f equals to z plus xy bar. Option C is f equals to z plus xy. And option D is f equals to z bar plus xy bar. Okay, so these are the options given to us. Now here if you have to minimize the expression, so here also we will take the help of K-map. K-map will help us to find the expression for this, minimal expression for this. Okay, so here it is 3 variables they have given. So let's draw the table. So table will be 2 cross 3 table we have to take out. So it will be 2 cross 4. Yes. Okay, so let's write the value for this. So we will consider this as x and yz. Likewise, we will consider. So I hope the table is visible. Okay. Now let's see. Let's put, so this will be 0, this will be 1, this will be 3, this will be 2, here it will be 4, it will be 5, it will be 7, and here it will be 6. So the table we have formed is of 2 to the power 3, because the variables are 3. So we want 8. So what we want? 8 columns. So it is 1, 2, 3, 4, 5, 6, 7, 8. So likewise we distributed x and yz. Okay. So yeah, let's do it. So here it will be 0. So our 1 will be on 0. Okay. So I'm making this like this. That means it is numbering. Okay. and the next one will be on 2, so it will be here. 5 will be here, okay, and 6 will be here, okay. So this is 0 0 and this is 1 0, okay. So this is 0 0 1 0 1 1 0 1, okay. So like this, likewise the numbering will be there. So here it will be, this is wrong actually, it will be 0 0 0 1 1 1 1 0, and this will be 0 0 and 0 1. Actually how it will be, this will be 0 0 and this is 0 0 1, this will be, then 0 0 1 1, this will be, and the 2 will be 0 0 1 0. So this is 2 to the power 2, 2 to the power 1, 2 to the power 2 and 2 to the power 3. So here the value will be 2, okay, and this value will be 1, and yeah, so value 2. So likewise you can do the numbering of this. Now if you will see how I have written here 4, so what it will be, 0 1 0 0. Now if you will do the numbering, 2 to the power 1, 2 to the power 2, 2 to the power okay, 0 1 2, and this is 2 to the power 3. So here rest all are 0, so the one value is there, so it will be 4. So likewise you have to check the numbering if it is correct or not, okay. So likewise you will check the numbering. And now, so here on 0 we have made 1, 2 we have written, 5 and 6, okay. Now it's time to do for the grouping. Okay, so let's check for the grouping. So which is the pair, you can see like it should be grouped, but we have to you have to consider the smallest group possible, okay. Sorry, the largest group possible you have to see. So this is which you can see that the largest group possible here, it will be, here it is 4 also, so here also we have to write. So this is 0 2 4 5 and 6, yes. So the largest group possible you have to see now. So the largest group, see, you can see this is the largest group possible, so these ones are covered, okay. Now we have to see for this one. So this one you can see, you can keep as one element also, but always you will look for the larger group. So one larger group will be 2 elements group will be the larger for this one. So here also the overlapping is done, but here the overlapping is done to cover this one. So this is not the problematic, okay. But here if the one is covered and again we are covering the one more time, so that is not you should do. One time covering of one is okay, but if the one is covered and still you are covering with other pair, that is not okay. So that is not, we will consider it as minimal pair, okay. So here you can see that all the ones are covered. So the expression we will get from here, it is x y bar plus z bar, x y bar plus z bar. So here the option D is correct. Option D is correct because the minimal expression, the simplified Boolean expression we got as this. So I hope you got the question. Let's move on to the next question. Okay, so this is the question we will see. Now this is 4:1 marks they have given us. Okay, so you should know the, okay, so let's write this. expression. So we have given the three variables. Okay, how many variables we have given here? A, B, C. Here here the lines they have given us, in S1 they have given B, S2 they have given C, and in the input I0 they have given us A, and I1 they have given here as A bar, I2 0 and I3 1. Okay, so these are the inputs. 4:1 marks they have given. So let's write the expression for this. So the expression you can easily get from this is F is ABC. F is ABC. The first one will be A, B bar, C bar. Okay, this is the expression we will get, because A is multiplied, and for 0 it will be S0, S1, S0 bar and S1 bar also. Okay, so likewise it will be, and next one will be A bar, B bar, C. This will be plus BC into 1, and the next one here, the next input is given here, I2 is given as 0, so we will not write the expression, we will only write for 3. Okay, so 3 will be B and C into 1, and this we will not consider, and this is A bar. Okay, A bar, B bar and C we considered. Okay, so this is the expression we got. Now let's minimize this expression. So actually we have to write the numbers of the mean term. Okay, what are the values we will get for the mean term, that we have to write. So A, B bar, C bar plus A bar, B bar, C and BC we have get. So here this is the complete expression, like A is also there, B is also there, C is also there. Here also A, B, C both are there. But here if you have to write the values of mean terms, so here complete expression, like complete variables we should have, but here A is missing. So how we will write A plus A bar. So this is how we will write A. So to complete the expression we have given, so this is equals to 1. Okay, this is equals to 1. So this one we can write as A plus A bar. Whatever the expression, whatever the variable is missing, we can write like this. So now we will get the complete expression. Okay, so it will be A, B bar, C bar plus A bar, B bar, C plus, now we will multiply this. So it will be ABC plus it will be A bar, BC. Okay, so this is how we will get the expression, the complete expression we will get. After getting the complete expression, let's look for the mean term values. So this will be 1, this will be 0, 0. Let's write this with different color. So this will be 1, 0, 0, and here it will be 0, 0, 1. Here it will be 1, 1, 1, and here it will be 0, 1, 1. Okay, so what are the values we will get here? Let's see. So F, A, B, C. Okay, so what are the mean term values we will get here? This will be, okay, this will be 1. Again, the value will be 3. The value we will get is 4 also, and the 7. Okay, so these are the mean term values we will get. So what is the correct option for this? So the option, okay, so the option is not given. So this is the correct answer. This is the correct answer for the question. And if the options are given, so you can mark this as the answer. Okay, so I hope this expression is clear. Let's move to next question. Okay, so this is the question which is given. Now let's see the options for this. So the option A is both y1 and y2. Okay, so let's see the options in the next page. So options for the previous question I am writing that question. It is the 16th. So the options are option A as output. So these are the options for question number 16. Let's read the question now. So consider the circuit described by the logic diagram given below, which is y1, y2. These are the outputs they have given, and the inputs are A, B, C, D, E, F, R. So the outputs they have given. So for A, the value is 1. For B, it is 0. For C, it is 1. For D, it is 1. For E, it is 0. For F, it is 1. Okay, now let's check the output for y1 and y2. So here, this will be 1. Okay, this will be 1. And this is the OR gate. So OR gate, this value comes out to be 1. Okay, now here in this, the value will be 1. And the XOR, this is the XOR. And here the input will be 1 itself. Okay, here the input will be 1. So this is the output for y1. Yeah, we will calculate the value, but let's see for the y2 itself. Now, from where the inputs will be here, the input is 1. So this input they have taken, the input they have taken here is 1, and here the input it is 1. So actually all ones are there, so it will be 1, and the NAND gate is, so it will be 0 here, the answer will be 0, and the NOT gate, here the answer will be 1. Okay, here the answer will be 1. So here in XOR gate, both the inputs are 1, so the value will be 0. And y2 value is 1. Okay. So if you will see the XOR gate input, XOR gate, logic gate. Okay. So if you will see that, so it will be A, B, and let's suppose the output is Q. So 0, 0, it will be 0. 0, 1, it will be 1. 1, 1, it will be 1. 1, 0, it will be 1. And 1, 1, it will be 0. So this is the logic gate truth table of XOR. So here you can see that 1, 1. So here the 1, 1, the value is 0. So that's why the output is 0. And the y2 output is 1. So y1 is 0 and y2 is 1. So this is the output we got. Okay. Now let's see the options. Let's see the options one by one. Both y1 and y2 have true as value. So 1 is considered as true and 0 is considered as false. But you can see that y1 is false and y2 is true. So that's why A is not the correct answer. Only y1 has true as input. So this is false. Why? Because y1 has false output. Okay. Only y2 has true as input. So option C is absolutely correct because y2 has true output. Only y1 and y2 have false as output. So both are not false, only y1 has false output. So I hope you are clear with this. So this is the learning which you got. Like you should be very clear with the truth table of XOR. Okay, so here the value we will calculate and likewise we will solve the question. So I hope the question is clear. Let's move on to the next question. Okay, so let's see the question. So this is the question, which of the following statements are correct? So the first statement is the total number of NAND gate / NOR gate is required to implement a full subtractor is equals to 9. So in full subtractor they are saying that NAND and NOR gate are required to as 9. So we'll see that when we'll make the full subtractor. And here in option B says the total number of NAND NOR gates required to implement a half adder is equals to 5. So we will also see when we will draw the half adder. Then they are saying NOR gate is preferable than NAND gate because it consumes less power. So we'll also see the explanation for this. And the D option is none of the above. Okay. So these are the options given to us. Now let's verify this one by one. So let's verify the option A. So for option A, we have to make full subtractor. Okay. So let's do it. So here it will be AB. The input will be okay. So let's make the full adder. Let's make the half adder using NAND first. So it will be okay, like this. It will be we'll take this as input. So it will be, if you can see this, so this is using the NAND half adder we are trying. So the option B we are trying here. Okay, so this is the option B, and so this is S, and this is C. So this is NAND gate half adder. So this is NAND gate half adder. So count how many number of NANDs we have made this. So it is 1, 2, 3, 4, 5. So 5 NANDs are required to make half adder. Now let's see for the NOR as well. Okay. So if we will see for the NOR, so it will be so let's first write the input. It will be AB. Okay. Then here it will be from NOR, be like this. We'll take the input from here A, and here from B the input will be so the input will be like this. Now from this we will take one input like this, and we'll again make one NOR. This will be the carry we will take. Okay, and here it will be the input will be from here. So here, okay, so this is how we will make. Please excuse me for the diagram, but I have shown you that the NOR gate half adder we have made. Okay, NOR gate half adder we have made. So this is the NOR gate half adder. So here you can see how many NOR gates are required to make half adder. It is 1, 2, 3, 4 and 5. So 5 NOR half adders are required. So our option is absolutely correct, which says that the total number of NAND NOR gates required to implement a half adder is equals to 5. So similarly, we can make the full subtractor, okay, by using NAND and NOR. So they will also require 5 NAND gates if we will make full NAND gate subtractor, and we will also get 9 NOR gates if we made it with, okay, with NOR subtractor. So for full subtractor 9 NAND gates are required, and for the full subtractor 9 NOR gates are also required. Means individually, like from here we made for NAND and NOR, so individually like that we can consider. Okay, So option B and options A and option A and option B are correct. Now let's see for the option C. So option C says that NOR gate is preferable than NAND gate because it consumes less power. But what the real explanation is, it is false. It is false because NAND gate consumes less power. NAND gate consumes less power than NOR gate. Okay, the statement is absolutely false. So the correct option is option A, B and C are correct options. Okay, so let's see the question. So determine which of the following are the essential implicants, prime implicants for the Boolean function, which is A, B, C, D, A, B, C, D, and the minterms given here as follows. Okay, so let's give me the option. So option A is B, C bar, option B is A, B bar, D, and option C is AC, and option D is A bar, C bar, D. So you have to find the essential prime implicants for this. And for this, we have to make the key map. So the variables are given here as 4. So we will make the blocks for 16. Okay, so it will be 4 cross 4. Okay, so this will be the K map for us. Okay, now let's write here. So it will be basically it will be AB and here it will be CD. It will be 0 0 0 1 1 1 1 0. Here also it will be 0 0 0 1 1 1 1 0. Okay, and now here the values will be 0 1 3 2. Here it will be 4 5 4 5 7 6. Here it will be 12 13 15 and 14. It will be 8 9 11 and 10. Now the values we will put here. Okay, so the values we will put here. So on 1 it will be 1, 3 it will be 1, 4 it will be 1, 5 it will be 1, for 10 it will be 1, for 11 it will be 1, for 12 it will be 1, for 13 it will be 1, for 14 it will be 1, and for 15 it will be 1. So this is how we will get. So let's make the table. Let's make the grouping. So you can see this, we can group this because this is the larger group which we can cover all the ones like this. Okay, so this is how we will do one grouping. This is also we can do the other grouping where we can cover the elements, and this is also we can group one more elements. So here you can see that all the elements are covered. Okay, but we will go for the maximum possible covering which we can do, and after that only we can see that which is the essential prime implicant. Okay, so let's do. So this is also one block which we can cover. Okay, this is also the block which we can cover. Okay, so this is the maximum grouping we done. Okay, so maximum grouping we done. Now let's go for the prime implicants. So if you can see this, so this is one group. So here all the grouping is done. So the one group which is where one is not fully covered will be the essential prime implicant. Okay, essential prime implicant. So if you can see that here in this group both the ones are covered, so this is not essential prime implicant. In this group only this one is covered, so that's why this group will considered as essential prime implicant. And here in this group also you can see that this two group, both the groups are overlapped by one, so this is not the prime implicant, essential prime implicant. And here in this group if you can see only this one is covered, rest is not covered, so this is considered as essential prime implicants. So you have to see the group where overlapping of one is not possible with whole ones. Like here this is one, here the one overlapping is done, here also overlapping, here also overlapping is done, so this is not the essential prime implicant. Okay, but if this is like this, if this is the group and here it is 1 and 1 and here one overlapping is done and this one is remaining, so this is we can consider as essential prime implicant, because the one word is left, it is not covered. So the other one has done the overlapping, but the one is left in this group, so this is essential overlapping. So this is you can see that in this group this one and this one is overlapped, so that's why we will not consider this as essential prime implicant. In this group of 4 you can see that only one is overlapped, so that's why we will consider this as essential prime implicant. And in this 4 group also one is only covered and rest are not covered, so that's why we will consider this group. So you can see that as you can see that, so this group is B C bar. Okay, this group, this vertical group is A bar, C bar, D. This group is A bar, B bar, D. Okay, so this is the group, and this is the group which is AC, and this is the group, this two is the group which is B bar CD. Okay, so this is, but the essential prime implicants only are B C bar and AC are essential prime implicants. So that's why the option A and C are absolutely correct. Option A and C are absolutely correct. So I hope you all got the explanations for all the questions which I have taken. In any of the question, if you feel that the question is not understood by you, the solution is not that explainable, okay, and you are not getting the explanation for the following questions, so you can simply go on to the app. There you can post the doubt, whatever the doubt you are having in the question. I'll take that doubt, I'll read that doubt, and I can take that question again in the RIC for you all, so that you can get the better understanding for the question and the explanation. So today we have the question number 18 we are going to discuss. Okay, so let's start it. The decimal equivalent value of IEEE 754 single precision floating number, okay, floating point number, and the number is given us. So we have to find the decimal equivalent value of this. Okay, so we, as you know, we have a formula regarding this. So first let's see what is IEEE 754 single precision floating point format. Let's discuss the format. Okay, so IEEE 754 single precision floating point format. Okay, so let's discuss this. So how the format will be? First there will be sign, exponent and mantissa. Okay, so let's make the block. So this block is divided in three categories. Not categories, just the division of block is done. So here in this block, for sign it is divided, for exponent, and after that here will be mantissa. Here we will have mantissa. And how the bits are divided here? So the sign will take 1 bit. Okay, sign will take 1 bit, and exponent will take 8 bits. Okay, and the mantissa will take 23 bits. So this is the general format for IEEE 754 single precision floating point. Okay, now what we have given this number. This number we have given. Okay, so let's see according to that. So if you will notice, see, this is the sign bit. So sign bit is 0. Okay, sign bit is 0. So that means we have positive number. So here the first bit is 0, that means it is positive number, and here if the first bit is 1, that means it is negative number. But in the question they have given us positive number. So this will cover 1 bit, and after that our exponent will be of 8 bits. Okay, so let me show you the exponent. Okay, so this is 1 bit and exponent will be of 8 bits. So this will be 1, 2, 3, 4, 5, 6, 7, 8. So from here to here we will have the exponent part. Okay, we will have the exponent part. So let's write it, the exponent part. So it is 1, 0, 0. So yeah, it will be I guess 4 zeros, right? Because here 1, 2, 3, 4. Yes, 4 zeros are there. 1, 2, 3, 4, 1, 1, 0. Okay, so like this it is. So this is our exponent part. Now the mantissa part. So all the 23 bits will be of mantissa. Okay, all the 23 bits will be of mantissa. So let's write the mantissa. 0, 1, 0, 1, 0, 1, 1, 0, and dotted up to 0, whatever the digits they have. So this will be of 23 bits. So according to the format, we divided this. We wrote the format. Okay. So now let's see. So the sign bit, okay, is 0, which is positive number. That clarity we got, that the number is positive or negative from first bit itself we can know. Then second, now we have to take out the value. So the formula for value is I am writing the formula. So this is actually the formula, which is 1.m, m is for mantissa, into 2 to the power e minus 127. So as they have said that find the decimal equivalent value. Okay, so this is the formula for value. Now one by one we will put everything in the formula and we will get the answer. Okay, we will get the answer. So what is our e? Let's calculate that. What is our m? 1.m. Let's calculate that, and then after we will do the multiplication and everything. Okay, so let's do it. On the next page we will do. Okay, so our e value is, which is exponent value, this is given as 1, 1 2 3 4 1 1 0. Now this is in binary format and we have to convert this binary format into decimal equivalent. So what that will be? 134. From this, from the RIC course, I am assuming that you all are very aware of conversion, like converting decimal to converting binary to decimal, decimal to binary. Every this conversion should be very clear to you so that it will really help. But in short, if I will tell you the conversion, so it will be like here you will write 2 to the power 0, 2 to the power 1, 2 to the power 2, and every value you will calculate likewise. Okay, so what the power here will be 0, 1, 2, 3, 4, 5, 6, 7, and 7 is 128 plus this value will be 128 and this value will be 0, 1, 2. So 4 plus 2 it will be 6. So it will be 4 plus 1, here 3 and 1. So likewise decimal equivalent value is calculated. Here the value is 2 power 7, here the value is 2 power 4 and here the value is 2 power 1. Clear everyone? So this will be 2 to the power 0, 1, 2. So here it will be 2. Here the value will be 2. Okay, so it will be 4, 5, 6 and 2 to the power 7 is 128 and here 6. So likewise we get 134. Okay, so the decimal equivalent value is 134. So I hope you got the conversion from binary to decimal. So this is how we will do. Okay, now this is our exponent. Exponent part we got. Now let's see 1 point m, this mantissa. So 1 point will be there and rest the mantissa we will write as it is. What is the mantissa? It is starting from 0. Okay, it is starting from 0, 1, 0, 1, 0, 1, 1, 0 and rest all zeros, and we will convert this similarly in this is in binary. Okay, now the formula part. So the value you have to calculate. So how the value we will calculate? So all the rest of the zeros we can exclude. So that doesn't mean anything. So 1.0101011. So this is only we will consider. So 1.0101011 only this only we can consider. Okay. Now into what is our exponent, which is 134. Okay, that we have to subtract by 127. It's already given in the formula. You can see exponent minus 127. This is the general format. You can also learn this format, like to calculate value. This is the formula. Okay, so formula you can keep remember and simply you have to put the values in it now. So what will be the values? So here this again will be 1.0101011 binary, and this will comes out to be, it will be 2 to the power 7. Okay, it will be 2 to the power 7. Now how things will be? So if we are multiplying, so see, if 1.0 is multiplied by 10, so what the value will be? Here 1.0 into 10, what is the value? So if we will calculate the value, so it will be 10, right? Because all the zeros will apply and here the point we will put. So it will be 10, right? So if we are multiplying 10, so the values are shifting in the right hand side. Like if suppose we have 0.1 and if we do it of square, so how? So here the values will be shifted. So 1, 2. So here the answer you will get is 1. Okay, here the answer you will get is 1. So you can clearly see the shifting of the values are there. So here the decimal equivalent is 10. So that's why we are able to shift the values likewise. So here also if you will see the decimal, so here also if you will see the decimal equivalent is 2. Here also 2. So likewise shifting will be there. Okay. So it will be 1, 2, 3, 4, 5, 6 and 7. So likewise shifting will be there if we will multiply 2 to the power 7. Okay. So likewise in 10 we saw the shifting because the number was equivalent to 10. So we are able to shift the values decimal. So here also we will shift the decimal by 7. Okay, because here 2 to the power 7 is given. So this, please remember this. Likewise we can do. So what will be the values without zeros? So it will be 1 0 1 0 1 0 1 1, and the binary equivalent is 2. Okay, so it will be 1 0 1 0 1 0 1 1. Yes, and if we will calculate this value, so the decimal equivalent value according to this will be 171 171. So the value will be 171. So this is the answer. So this is how you should do. You should first know the format, then the formula you should know, and after that you should know how to apply in the formula. Okay, so I hope this question is very well clear to you. Okay, so let's move to next question. So the next question is, which of the following are true for twisted ring counter, also known as Johnson counter with NFFS? So here, let me give you the options. Let me give you the options here. Then we will discuss the options one by one. So first of all, the first option is lockout. Lockout may occur when counter enter into unused state. So this is the first one, and the second one is in normal Johnson counter frequency at output of each flip-flops is 2f by n, and duty cycle is 50%. Okay, so this is the option B. Now let's look for the next option. Let's look for in the next page. We will see. So the option C is in normal Johnson counter frequency at output of each flip-flop is f by 2n. Okay, and duty cycle is 50%. Okay, and the option D is none of the above. So this is our options. Okay, this is the options they have given. Now let's see for the solution. Okay, so it's visible. Okay, yes. So which of the following are true for twisted ring counter, also known as Johnson counter with NFFS? Okay, so this is actually a kind of theoretical question. So here if you will see the options, so the correct options are option A and option C, which says that lockout may occur when counter enters into unused state. So this is true for Johnson counter, and the C is in normal Johnson counter frequency at output of each flip-flop is f by 2n, and the duty cycle is 50%. So this is also correct. Okay, this is also correct. So what is the difference here? Okay, so here in B the formula is not correct. The statement is correct, but here the formula is not correct. But in C, the formula is correct. So that's why option B is incorrect. Option C is correct and option A is correct. Okay, so let's see the reasoning for option A. Okay, let's see the solution. So the solution for this is if input frequency is f, the output frequency of ff is f by 2n. Okay, so you should keep remember this point. So this is the frequency. Okay, and the next point is the maximum count by this counter. The maximum count by this counter is 2 to the power n minus 1. Okay, so here in the option they have given us none of the above. They may also give that maximum count by the counter is 2n plus 1 or 2n divided by 4, something like that they can give. So simply you should know the maximum count by this counter is 2 to the power n minus 1, and the input frequency, which we denoted by f, so the output frequency of FFS is f by 2n. So these 2 points you should know. So the correct answer is A and C. Okay, so the correct answer for this question is A and C. So this was all a complete theoretical kind of question. Okay, so let's move to the next question. So the next question is, given a 4-state ripple counter with progression delay of each flip-flop is 30 ns, 30 nanoseconds, and strobed signal operate at 30 nanoseconds, the minimum clock time period is, and in nanoseconds they have asked. Okay, so as you all know that they are asking about the time period. So the formula you should know. Okay, the formula you should know. So it is the formula is solution. So we know that t, which is time period, which is greater than equals to, okay, because they have asked the minimum one. So that's why the symbol is there. And TPD, because the progression delay is given, which is NTPD, and 4 states are given, so which is n, which is generally n. Okay, plus time of strobe signal also they have given. Okay, so this is the general formula. Now we will put this. So n they have given us 4. Time period, which is propagation delay, they have given us 30, plus strobe signal they have given us 30. Okay, so this is the basic general formula, and the answer comes out to be 50 ns. So the minimum clock time period is 150. The minimum clock time period is 150 nanoseconds. I hope you got. Okay, so this was a very simple question with a general formula, and then we have to put only the values. Okay, so I hope the question is clear. Let's move on to the next question. So the data in a register is this, the binary format they have given, and is equivalent to, okay, so is equivalent to, okay, so let's see the options. It is minus 54 if it is sign magnitude notation. Okay, option B is minus 54 if it is if it is ones complement notation, and the C is minus 73 if it is 2's complement notation, and D is minus 74 if it is 2's complement notation. So these are the options given to us. So we have to verify which is the correct one. Okay, so let's see the solution for this. So we should see the solution in the next page because we will have so much space there. Okay, so the solution we will see. So let's write the data which is given to us. So the data in the register, so which is given to us is 1 0 1 1 0 1 1 0. Okay, so this is the data given to us. Yes, this is the data. Okay, now you can see here the first symbol is 1. So what that means? That means that sign bit is 1. Okay, sign bit is 1. Number is negative. Okay, so our number is negative. Then now if we'll see sign magnitude notation, if we will see sign magnitude notation, so it will be sign magnitude notation will be 1 0 1 1 0 1 1 0, so which is 54, but here the first bit is negative, so that's why it will be minus 54 and it will be equivalent to 10. So the base is 10 and the value is minus 54 because we note that the first bit is 1, so it is the negative number. Okay, and now if we will see for the ones complement, okay, so sign ones complement. So I hope you all know how to do ones complement of the number. So if this is the number, so the ones complement we will have is, so this all the bit of 1 will be 0 and 0 will be 1. So this will be 0 1 0 0. This will be 1 0 0 1. Okay, so it will be 0 1 0 0, the 1 0 0 1. So this will be in binary and we have to convert that. Okay, so it will be 1 2 3 4 5 6 7, sorry, 0 1 2 3 4 5 6. So 2 to the power 6 is 64, I guess. Yes, and this will be 1 to the 2 to the power 0 will be 1, 0 1 2 3, and 2 to the power 3 will be 8. We have to add this, so it will be 9. Okay, it will be 9. So 9 plus 4 is 13, 3 1 and 73. So the value will be 73, but here as we all know that the number is negative, so that's why it will be minus 73. So it will be minus 73 and this is in the decimal. So I have told you how to convert this. This is a simple calculation which we did. Okay, so this is how we will do. Yes, now let's see, this is the ones complement. Now let's see for the twos complement. So sign for twos complement, so twos complement you have to just do plus 1 here in ones complement. So the value will be 0 and here it will be 1. Okay, here it will be 1. So it will be 64, 8 and here it will be 2. So 10, 4, 1, 74 the value will be. Okay, so you simply all know this, that here in 2's complement we will do just plus 1 to this. It will be 0 plus 1. So the number will change like this and the sum will be 74. But the first digit is negative, so that's why we will say that it is minus 74 in 10 equivalent. Okay, so this is the solution we got. Now let's check it. Let's check through options. So minus 54, is the value minus 54? Yes, we derived. So it is in sign magnitude notation. Okay, so yes, option A is correct. Minus 54, it is sign magnitude notation. And 1's complement is 1's complement minus 54? No, it's minus 73. So this B option is incorrect. C option is also incorrect because minus 74 is 2's complement notation. So that's why you can see that option A and option D are absolutely correct. Okay, so we will write it. A and D are correct. Okay, option A and D are correct. Okay, so this is hiding. So A and D are correct. Yes, it is visible now. So I hope you got the solution. Let's move on to the next question. Now here they have asked us for the decimal equivalent of the given 2's complement number is, and the number they have given. Okay, so 2's complement number is given. Okay, so let's see this. So the first bit we always see is of what we see. First bit is sign bit. So this is actually a negative number because the sign bit is 1. Okay, so let's see what is the given. Okay, so let's write the solution. The given 2's complement, number. Okay, so the number given is 1 1 0 1 0 1 0 1 1.1101. So this is given. Here you can see that sign bit is 1, which is the number is negative. So sign bit is sign bit is 1. So number is negative. So the sign bit is 1. So likewise we will change the number. See, if we have to take out the decimal equivalent complement of 2's complement, so we will convert this into 1's complement first. Okay, we will convert this into 1's complement first, and then on the 1's complement again we will do 2's complement and we will get the number in the decimal form. So let's see, first we will do into 2's complement. So it will be 0 0 1 0 1 0 1 0 0 point 0 0 1 0. So this will be the 1's complement. Okay, 0 0 1 0 1 0 1 0 0. So this will be the 1's complement, and after that we will do a 2's complement and we will get the decimal equivalent. So it will be 0 0 1 0 1 0 1 0 0 dot 0 0 1 1. So this is the 2's complement, and now we will do the decimal equivalent. So decimal equivalent will comes out to be 84.1857. 84.1875 will be the answer, will be the decimal equivalent. So the question is saying the decimal equivalent of given complement 2's complement number is. Okay, so this is the method to convert. Okay, so if you will check this, so the number will come out to be like this. Okay, so yes, I hope you know the conversion. So simply you can convert this number into the decimal equivalent. Okay, so and it will be actually minus sign, because here we find that the number is negative. So that's why minus sign will be there. So what will be the number? Minus 84.1875 will be our answer.